All right. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, just a reminder, my YouTube channel is Math with Mayo, and this class, Math 95, there'll be a playlist there that'll say Math 95 Fall 2021. Also, please communicate with me through emails, not text or phone calls, but through emails. And if I don't get back to you right away and you just have to have an answer, I have another answer for you. What you can do is you can go to the Math Center, okay? The Math Center is, you can go there to see the Zoom ID down at the bottom, 509-574-6827. It is available Sundays 3 through 9 p.m., Monday through Friday 10 a.m. to 4 p.m., and Monday through Thursday 6 to 9 p.m. And if you're frantically writing this down, don't panic. You can always go back and look at the beginning of the YouTube video and it'll be there. But that Math Center is open those hours. So like I say, I check my emails from time to time, but it's not like I sit there waiting for you to respond. So we have the Math Center as well. All right. Today, we're going to look again at section 6.3, factoring trinomials of the form ax squared plus bx plus c, where a is something other than a 1. Only instead of using the grouping or the ABCPS method, as I call it, we're going to use the trial and error method, or the guess and check, or the trial and check. It's got all these different names to it. But anyway, name doesn't matter. But just a reminder, what I want you to do today is I want you to use this new method on tonight's homework to try and expose yourself to both methods. Then moving forward, you can use any of the methods that you want, either of these, but I want you to try it because sometimes you look at it, my explanation is like, oh, that's terrible, I can't do it. And then you start doing it, it's like, oh, this isn't so bad. So try it, we'll see. Okay, now, again, as I mentioned, we're going to start with problems in the form ax squared plus bx plus c, where a is something other than a positive 1. Okay, now let's go ahead and start with this problem. 3x squared plus 4x plus 1. So here we have a trinomial. It's in standard form. There's no greatest common factor. If there was, we'd take it out first. The leading coefficient is not a 1. So now we're going to apply. Let me look here really quickly. I'm trying to remember what this method is called. Let's see here. Come on. Just so if you see it referred to. Trial and check. It's called trial and check. But I've seen it as trial and error. I've seen it as guess and check, FOIL method. This one, in this book, it's called trial and check. All right, so you're on trial, you have to write a check to get out of jail. Just kidding. Okay, what we do is we take the leading coefficient and we write all of the factor pairs whose product is 3. And I should say all of the positive factor pairs. So basically 3 and 1, that's pretty much it. Okay, then we take the constant term at the end and we write all the factor pairs whose product is 1. Now, I could also use -1 and -1, but because this is positive and this is positive, there's no way it can be negative. So we're just going to take a look at that. Okay, this example is pretty simple. It's going to get more complicated as it goes. Now we're going to take these numbers and we're going to create sets of factors. We're going to use these two numbers at the beginning, along with the x, and these two numbers at the end. Okay, now we're going to take one of these times one of those, and one of those times one of those, and try and come up with a 4x in the middle. Well, let's see, 3x plus 1x is 4x. So that works. Okay, because these two numbers are the same, if we switch them around, it wouldn't make any difference. And if you're confused by this one, don't panic. As it actually gets more complicated, I think it will become more clear what I'm trying to get you to do. But basically, I didn't have to use the grouping method. I just looked at that and said, well, these have to go in the front, those have to go at the rear. There's their answer, okay? But they're not all this simple. Let's see here. Let's take a look at this one. 7t squared plus 12t plus 5. So here is a trinomial in standard form with a leading coefficient that is not a 1, and there is no greatest common factor I can take out. Factor pairs of 7, 7 and 1. Factor pairs of 5, 5 and 1. All right. So one possibility is 7t, 1t plus 5 plus 1. But another possibility would be 7t, 1t plus 1 plus 5. In other words, I can take the 7 in front and the 1 at the rear, but I can have the 5 in either place. Okay. So looking at these combinations, what I'm really looking for is how to get 12t in the middle. So where does that come from? That's the inner and the outer. Inner and the outer. Well, this first one, if I multiplied it out, I'd get what? 7t squared up front and plus 5 at the end. But in the middle, I'd get 7t plus 5t, which is 12t. So this is the correct answer. Now this one, I'd get 7t squared up front and 5 at the end, but the middle terms would be 35t plus 1t, which would be 36t. So it doesn't work. So basically, by creating these factor pairs, all of our possible answers are going to give us the first and last term correctly. It's the middle term that we have to match. We've got to get the numbers in the right places so that we come up with the middle term, the 12t, by doing the inner and the outer products. Okay, let's take a look at another one. 15a squared minus 28a plus 5. This one's going to get complicated. All right. So it's a trinomial in standard form. There's no greatest common factor, and the leading coefficient is not a 1. 15 could be 15 and 1 or 5 and 3. 5 could be 5 and 1. Oh, but the middle term is negative, so we could also have what? -5 and -1, right? Okay. In fact, we're going to have 2 negatives to get a negative term in the middle, aren't we? So these numbers go in the front, these numbers go at the rear. So I've got 15a and 1a minus 5 minus 1, or 15a and 1a minus 1 minus 5, or 5a and 3a minus 5 minus 1, or 5a and 3a minus 1 minus 5. Do you see what I'm doing in terms of possibilities? I'm going to take these two as my leading coefficients in the binomial factors, these two as my last terms in the binomial factors, but I don't know which combination to go with, okay? So I've got the -5 first and the -1 last, then I switch them, then I use this group, -5 first, -1 last, and then I switch them. Every one of these factor pairs, if you FOIL them together, multiply them out, your first term would be 15a squared, and your last term would be plus 5. But I'm looking for minus 28a in the middle. Again, the inside and the outside. So this would be minus 15a, minus 5 more a would be minus 28. So it's not that one. This would be minus 75a, and this would be minus 1a, which would be minus 76a. So it's not that one. Okay. Let's see. This would be minus 5a, minus 15a, which is what? Minus 20a, not that one. This would be minus 25a minus 3a is minus 28a. Bingo. And I didn't deliberately put the right answer last. I honestly didn't. I just wrote them out as I saw them. So here's the possibility, or excuse me, there's the correct answer. You get 15a squared minus 28a plus 5. Now, this is a lot of writing. If in doing this method, you have to write out every combination to see it, to calculate which one's correct, you're probably not going to like this method, even though I want you to try it, okay? If, however, you can do all the multiplication and addition manipulation in your head, then it's not too bad. And let me explain what I mean by that. So what are we doing here? We're taking one of these times one of those, getting that product, plus the other of those times the other of those, and getting that product, and adding them together to come up with the middle terms coefficient. Well, let's see. 15 times negative 5 is negative 75. 1 times negative 1 is negative 1. Negative 75 plus negative 1 is negative 76. Okay, that didn't work. Now we're going to switch them. We're going to say 15, oops, I didn't switch it. 15 times negative 1 and 1 times negative 5. Okay. What does that give us? Well, let's see. Negative 75 minus 1, negative, or is that the one I just did? Nope. Well, 15 times negative 1 is negative 15. 1 times negative 5 is negative 5. Negative 15 plus negative 5 is negative 20. That's not giving us that either. Okay, so that means this doesn't work with these. So it's got to be this. Okay. So now I'm going to take 5 times negative 5 is negative 25. 3 times negative 1 is negative 3. Negative 25 plus negative 3 is negative 28. Bingo! I've got the right combination. So now what was that? Let's see. I had a 5a and a 3a, and I went 5 times negative 5. So that negative 5 would have to go over here, because if it's here, you wouldn't be multiplying it by the 5a, and then a minus, oops, minus 1 goes there. Okay. Now, even that was a little bit tedious, but if you can get fairly quick at this, then it's not so bad. So if you can do that, then I think you're going to prefer this method. But most people shy away from it and tend to like the other method, just for whatever reason. But I need to expose you to both of them, and you need to practice both of them so that you can see. Realistically, this method works great when there aren't a lot of combinations, where the other method maybe is quicker if there's a lot of combinations to consider. Also, you don't want to use either this method or the one we did yesterday when the leading coefficient is a 1. You just go back and do the thing like, you split it up, and the product and the sum go here and here, okay? Don't use this method on problems like 6.2, because then it takes you way longer than it needs to. Okay, let's take a look at another example. 4b squared plus 15bc minus 4c squared. So I've got 4 and 1, 2 and 2, negative 4 and 1, 4 and negative 1, negative 2 and 2. Well, 2 and negative 2 would actually, this would be the same as that one. So we don't need it. Okay. So I've got 2 different sets of possibilities at the front and 3 different sets of possibilities at the rear, but again, in different orders. So again, I'm going to do it the long way. These are all the possibilities. Okay. We could have 4a and 1a and minus 4 and plus 1. We could have 4a and 1a and plus 1 and minus 4. We could have 4a and 1a and plus 4 and minus 1. We could have 4a and a and minus 1 and plus 4. Okay. We could have 4a and 1a and minus 2 and plus 2, 4a and 1a and minus 2, whoops, plus 2 and minus 2. That's just with this one. Now, over here, we could have 2a and minus 4 and plus 1. We could have 2a and plus 1 and minus 4. Oh, because these numbers are the same, this is actually the same as the one above, isn't it? Okay, so I don't need that. And then I could have 2a and plus 4 and minus 1, 2a and minus 2 and plus 2. So there are, what, 9 unique possibilities. Every one of these, if I multiply them together, I get 4b squared up front. Oh, what have I left out? In fact, how did I change from b to a? What did I do there? I'm surprised nobody stopped me. I forgot to switch variables.
I was going to say something, but I wanted to wait till you were done.
No, if you think I'm messing up, just jump right in and interrupt me. I will not be offended. I would much rather you do that than for me to have spent 10 minutes droning on, messing people up. Okay. But you know what? Even this isn't correct, right? What have I left out?
The C.
Correct, the C's. Okay. Point being, though, I've got all these different combinations, right? Only one of them is going to give me plus 15BC in the middle. So let's see. I know that the first two are going to give me this, and the last two are going to give me that, right? Just from the way I found these. But I'm looking for 15BC in the middle. Let's see. 4BC minus 4BC is 0BC. That's not going to work. Minus 16BC plus 1BC is minus 15BC. Oh, interesting. Right number, wrong sign. Let's see. Minus 4BC plus 4BC. That's going to cancel. 16BC minus B. Oh, there we go. Right there. There's our answer. Okay. So let's make sure. If we multiply that together, we get 4b squared plus 16bc minus bc minus 4c squared. So 4b squared plus 15bc minus 4c squared. So here it is. Okay. Now, again, tedious, a lot of work. And in fact, I think that's why I tend to screw it up, is because there's so much writing involved. But you could fast track it by doing this, okay? Or I should say, if you can fast track it, then it's not so bad. What I want to do, let's erase all the evidence here. Okay, so I'm going to take one of these times one of those, get that product, which is negative 16. Then I'm going to take the other of these times the other of those. 1 times 1 is 1. Negative 16, the first product, plus the second product. Negative 16 plus 1 is negative 15, and I need positive 15. So that one's not going to work. My sign was wrong. What if I switch my signs? So I'm already going, what about this one and that one, along with this one and that one? There's the black combination, there's 16, and then the red, minus 1 is 15, okay? So I got it second try just because I thought, oh, the signs are switched. But again, it's something that takes practice. But this one, I did it quicker than it probably would have taken me to use the grouping method. But again, I got used to how to look at it without having to write out all the possibilities. And you might have to write out all the possibilities, and that's okay. Get you used to the idea, but I want you to look at these and, can you tell which method I prefer? It should be pretty obvious. Nobody wants to talk. Yeah, I prefer the other method. Most students prefer the other method, but there will be some of you that can do this whole process fairly quickly without having to write everything out. And you'll think, oh, this method's better. And that's great. Now let's finish this problem. So I figured out it was 4b and then 1b right up front, and then plus 4 and minus 1. But the 4 was multiplied by the 4. So the plus 4 goes over here and the minus 1 goes over there. Here's a C, there's a C, everywhere is a C. So now we've got 4b squared plus 16bc minus bc minus 4c squared, 4b squared plus 15bc minus 4c squared. So there is our answers. All righty. Let's take a look at another one. 8m squared plus 5m minus 10. So 8 could be 8 and 1, 4 and 2. Negative 10 could be negative 10 and 1, negative 5 and 2, negative 1 and 10, negative 2 and 5. All right. So I'm looking for the combination where one of the first group times one of the second group, that product, plus the other of the first group times the other of the second group, that product added together gives us 5. Okay. I'm not going to write out all the factors. I'm just going to do the numbers thing and let's see what happens. So 8 times negative 10 is negative 80. 1 times 1 is 1. Negative 80 plus 1 is negative 79. So that combination didn't work. Let's switch the order. 8 times 1 plus 1 times negative 10. That's what? Got what? 8 times 1 plus negative 10 is negative 2. That doesn't work. So that means that this group with that group doesn't work. But the problem is we can't throw out either group because the first group might work with something else on the second list. And the top number on the top, this group might work with the bottom one over here. So I got to keep going. Okay. All right. So we're going to take the first one here with the first one there, the second one here with the second one there. Negative 40 plus 2 is negative 38. So that didn't work. Oops. So we're going to take the first one here with the second one there, and the second one here with the first one there, which is what? 16 minus 5 is 11. So we got what? 16 plus negative 5 is 11. So that one didn't work either. Okay. So now we're going to take this one with that one, which is negative 8. That one with that one, which is 10, which is 2. So that doesn't work. Isn't this fun? Then we're going to take 8 with the 10, which is 80. 1 with the negative 1, which is negative 1, which is 79. So that one doesn't work. Then we're going to take 8 with negative 2, which is negative 16. 1 with 5, which is 5. Negative 10 plus 5 is negative 5. So that one doesn't work. Then we're going to take 8 with, wait, let's see. Okay. Oh, that's a 16. No wonder I was like, okay, I've messed up there, haven't I? Let's see. That's the 7th. Yeah, that was supposed to be negative 16 plus 5, so it would have been negative 11, wouldn't it? My bad. But it still isn't the 5, so I lucked out. Then we're going to take the 8 times the 5, which is 40, and then the 1 times the negative 2, which is negative 2, which is 38. Okay, and the reason, part of the, not to get out of my mistake, but part of it is if I was doing this and for nobody watching me, I wouldn't be writing all this down. I'd just be doing it in my head. But if I do it in my head, you can't see, you can't see what I'm doing. So it doesn't work that way. I still haven't gotten to 5, have I? Okay. If you think I've made a mistake, please jump in there. So we've eliminated 8 and 1. It didn't work with any of those. None of them gave us 5. So now let's do the 4 and the 2. Okay. 4 times negative 10 is negative 40. 2 times 1 is 2, and that's negative 38. That doesn't work. Four times 1 is 4. 2 times negative 10 is negative 20, so that's negative 16. That doesn't work. So I basically eliminated that one now. Okay. And let's take 4 times negative 5 is negative 20. And 2 times 2 is 4, which is negative 16. 4 times 2 is 8, and 2 times negative 5 is negative 10, which is negative 2. But now you can't read it because I've made it all sloppy. Okay. It's not that one either, is it? How about 4 times negative 1? That's negative 4. 2 times 10 is 20. Negative 4 plus 20 is 16. That didn't work. I've taken to just doing it in my head. So it's negative 1, 10. How about 4 times 10? That's 40. 2 times negative 1 is negative 2. That's 38. I wish you could see me just pointing my fingers there. 4 times negative 2 is negative 8. 2 times 5 is 10. That's 2. 4 times 5 is 20. 2 times negative 2 is 4, 16. Basically, this one's prime. Wasn't that awful? Because I had to try all those different possibilities to determine that it was prime. Yeah. Because we had so many combinations here and so many combinations there. At this point, how many of you have given up and said, you know, there's no way I'm going to like this method? Any of you? Give it a try. I deliberately picked some that were awful just to show you how awful it can get. Okay, let's do some more here because I know you want to. We've got this following thing. 20y squared minus 93y minus 35. This is a trinomial. It's in standard form. There's no greatest common factor. The leading coefficient is not a 1. 20 is 20 times 1, 10 times 2, 5 times 4. Negative 35 is negative 35 times 1, 35 times negative 1, 7 times negative 5, negative 7 times 5. Wow, that's just horrible, isn't it? All those combinations. This one's not prime, by the way. So here's what I'm going to do. I'm going to just talk this through, but I'm not going to draw anything. I'm not going to draw them all out. Just again, show you how this could be done. And I'll take it slowly. I'll write down some results, but I'm going to start with, I lied, I'm going to actually write some things out. I'm going to start with that group, 20 and 1. Okay. I'm looking for negative 93. So I'm looking at the top one on the left. I'll just do this. In the top one on the right. 20 times negative 35 is huge. 1 times 1 is 1. Huge, negative huge plus 1 is not going to be negative 93. That's way, I mean, what is it? Negative 700, I think it is. Yeah. So it's be negative 700 plus 1, negative 699. Switch them around. 20 times 1 is 20. 1 times negative 35 is negative 35. 20 plus negative 35 is negative 15. So the one circled on the left and the one circled on the right, those combinations aren't going to work. Okay. Let's go with this one and this one. 20 times 35 is 700. 1 times negative 1 is negative 1. 700 plus negative 1 is 699. 20 times negative 1 is negative 20. 1 times 35 is 35. Negative 20 plus 35 is 15, not negative 93. Are you okay with that? Can you follow what I'm doing here? Well, we'll find out. Okay. How about we'll do a silver one. Let's see here. We're going to do this one with that one. 20 times 7 is 140. 1 times negative 5 is negative 5. 140 plus negative 5 is 135. That didn't work. Switch them around. 20 times negative 5 is negative 100. 1 times 7 is 7. Negative 100 plus 7 is negative 93. Bingo, we have a winner on aisle 7. Okay, so it's this and this. So what does that mean? That means I'm going to have 20y and 1y and 7 and negative 5. Oh, let's see. The 20 got multiplied by the negative 5, so it's got to be over here, and the 7 has to be over there. So that gives me 20y squared minus 100y plus 7y is minus 93y minus 35. So there's the answer. Okay. Any questions on this one? Is anybody even still there, or did you already fall asleep? No one here. You're here. Okay. Are you able to follow this at all, or is it just like way too fast?
I'm following, but it just seems so much more complicated than the other way.
That's kind of what I think. A lot of my colleagues don't like this method, but I find that most students prefer it. Excuse me, I said that wrong. A lot of my colleagues prefer this method as opposed to the grouping method, but most of my students prefer the grouping method. I was teaching this back when it wasn't even in the book, but anyway, because some students introduced it to me, they'd learned it in high school. All right, well, I've tortured you all I'm planning to with this method, but I do want you to give it a shot, try it, see, you know, some of you will decide that maybe you like this. Ideally, I would use this method on ones, for instance, the very first one I did, this thing here, okay, where it's got to be a 3 and a 1 and a 1 and a 1. There's really only one possibility there. That's quicker than going through the whole grouping thing. But when you get something like this, where you've got, you know, so many possibilities, maybe the grouping method would be quicker. That's just, so you kind of get it. You want to get exposed to both of them, figure out which one you prefer, and go with that one. All right. That's all I've got for you for today. So for tonight, do 6.3 part 2. I will be back at 1:15 with an office hour if you have any questions. So I'm going to go ahead and stop the recording.